The likelihood that there is life elsewhere in the universe is growing stronger. The transit and radial velocity approaches have revealed a large number of exoplanets that may resemble Earth and perhaps harbor life. The presence of water molecules, haze, and clouds on the exoplanet WASP 96b, as revealed by the JWST, suggests that the planet may have habitable conditions. The many worlds interpretation of the term multiverse refers to the existence of numerous other universes or realms beyond our own. A quantum system may collapse into a single state in quantum physics upon observation, but in the many worlds interpretation, the system breaks into several states, each representing a distinct conclusion. The concept of a multiverse broadens our understanding of the possibilities in the cosmos. Even though it is still very theoretical and lacks solid proof, with the help of telescopes like the JWST, we are able to gain further insights into the structure, composition, and history of the vast and intriguing observable universe. We are reminded that there is much more to learn by the notion of extraterrestrial life and the possibility of a multiverse. Verifying the existence of a multiverse is a challenging task, and while some philosophers and scientists find the idea intriguing and possibly helpful in understanding some facts, others remain unconvinced. The idea that there could be more than one universe is as plausible as Schrödinger's cat, since we have no idea what exists outside of the cosmos. Is there a dark flow? The dark flow is a phenomenon that was first postulated in 2008 as an explanation for why, given the known distribution of matter in the universe, some galaxy clusters appear to be moving faster than expected. According to the theory, these galaxy clusters might be pulled in a specific direction by dark or invisible matter or energy. However, there is disagreement within the scientific community over the presence of dark flow. While some investigations have been unable to prove its presence and have instead attributed the apparent motion to systematic measurement mistakes, others have suggested that it might be real and could be created by a huge, enormous structure in the cosmos. Dark flow could potentially exist outside of the visible cosmos. Is there really a black hole? A black hole is an area of space where light cannot escape due to the intense gravitational pull. Black holes, which can have masses ranging from a few times that of the Sun to millions or billions of times that of the Sun, are created when a star collapses at the end of its life. It is challenging to estimate the likelihood that black holes exist in the unobservable universe. Although the quantity and properties of black holes in the unobservable cosmos cannot be determined with certainty, it is highly probable that there are many of them throughout the universe. Is dark matter real? It is believed that dark matter, a hypothetical type of matter, accounts for about 85% of all matter in the universe. It is difficult to directly detect because it does not interact with light in the same way as ordinary matter, hence the name dark. Its gravitational pull on observable matter and the way it bends light from far-off objects suggest its presence. The scientific community acknowledges the existence of dark matter, though little is known about it, and its nature remains unknown. Scientists have various theories regarding its potential qualities, but none of them have been proven. Another enigma that might be resolved by peering outside the confines of the observable universe is dark matter, which could consist of particles that have not yet been detected. NASA and exploration future. The James Webb Space Telescope, JWST, was built to capture photos and spectra of solar system objects as well as observe the universe's farthest-reaching objects. It is anticipated to investigate exoplanet atmospheres and offer new perspectives on the genesis and development of galaxies and stars. The JWST is still in the process of being launched and commissioned, but it is expected to significantly advance our knowledge of the cosmos. It might discover novel and unexpected phenomena that could contradict what we currently know about the universe, possibly leading to the discovery of extraterrestrial life earlier than predicted. Meanwhile, in order to gain a deeper understanding of the physics governing the observable universe and to discover more about its composition, structure, and history, scientists and researchers continue to study it. Until then, there remains both curiosity and anxiety associated with the unknown that lies outside of our observable cosmos. The question of whether we are alone in the universe has fascinated humankind for centuries. From ancient philosophers to modern scientists, the search for extraterrestrial life has remained a pivotal aspect of scientific inquiry. The discovery of exoplanets, planets outside our solar system, has significantly altered the landscape of this search. The sheer number of these exoplanets that may possess Earth-like qualities suggests that the potential for life beyond our planet is not only possible but increasingly plausible. As telescopes like the James Webb Space Telescope peer deeper into the universe, the chances of finding planets with conditions conducive to life rise exponentially. One of the most important factors in determining whether a planet might support life is its location within the habitable zone of its host star. This zone, sometimes called the Goldilocks zone, is the region around a star where the temperature is just right, neither too hot nor too cold, for liquid water to exist on the planet's surface. Liquid water is considered a key ingredient for life as we know it, and its presence on an exoplanet increases the likelihood that life could exist there. Researchers have used this criterion to identify potential candidates for further study. Some of the most promising exoplanets discovered so far lie within the habitable zone of their stars, and the JWST is poised to provide invaluable data about these distant worlds. The discovery of water vapor in the atmospheres of exoplanets is another breakthrough. One of the most notable examples is the detection of water vapor on the exoplanet K2-18b, a potential candidate for supporting life. The presence of water vapor, combined with other atmospheric characteristics, has fueled speculation about the potential for life on planets far from our solar system. Scientists are now focusing on analyzing the atmospheres of these distant planets to detect biosignatures, molecules or gases that could indicate biological activity. In addition to water vapor, scientists also look for other potential signs of life, such as methane or oxygen, which, when found together, might indicate biological processes. The possibility of life beyond Earth also ties into the broader concept of panspermia, which suggests that life may not have originated on Earth at all, but rather been transported here from elsewhere in the universe. While this idea has not been proven, it has garnered interest as new discoveries in astrobiology continue to suggest that the building blocks of life may be more widespread than previously thought. Some researchers believe that meteorites or comets, which have impacted Earth over the millennia, could have carried microscopic life forms or organic molecules that seeded the planet with the ingredients for life. This theory, although speculative, opens up the fascinating possibility that life is not unique to Earth but is instead a widespread phenomenon across the universe. In parallel with the search for life, the study of the universe's origins and its ultimate fate continues to captivate scientists. The Big Bang Theory, which posits that the universe began as a singularity, a point of infinite density and temperature, around 13.8 billion years ago, is the leading explanation for the universe's origin. Following the Big Bang, the universe expanded rapidly in an event known as cosmic inflation, cooling as it grew and allowing for the formation of the first stars and galaxies. This process, which is still ongoing, is responsible for the current structure of the universe, with galaxies, stars, and planets scattered throughout space. The JWST, with its advanced infrared capabilities, is providing us with a closer look at the earliest stages of the universe. By observing light from galaxies formed just a few 100 million years after the Big Bang, scientists can begin to unravel the mysteries of cosmic evolution. These observations could help answer some fundamental questions. How did the first stars and galaxies form? How did the universe evolve into the complex structure we see today? And perhaps most intriguingly, how did the fundamental laws of physics as we understand them come to be? By observing the oldest and most distant galaxies, the JWST is pushing the boundaries of our understanding of cosmic history.